Bismillahirrahmanirrahim. Welcome to PMDC online lecture room. This is Shaheryar Qureshi, Associate Professor of Physics. Dear students, today we are going to discuss a very important topic, electromagnetic waves. This topic is taken from chapter 15, Alternating Current Circuits. Dear students, the existence of electromagnetic waves depends on two facts. First, a time varying magnetic field acts as a source of electric field, which means changing magnetic field induces current. And second, and less familiar, a time varying electric field acts as a source of magnetic field. Actually, first part was related with chapter 13, electromagnetism, and the second part was related with electromagnetic induction, chapter 14. Thus, a time varying field of either kind gives rise to a time varying field of other kind in the neighboring region of space, which means when current changes, it induces magnetic field, and when magnetic field changes, it induces current. Therefore, we can say time varying electric and magnetic field can propagate through space as a wave, because both are producing each other simultaneously. Such waves carry energy and momentum and have a property of polarization. A wave can be sinusoidal, in which case the electric and magnetic fields are sinusoidal function of time, which means electric field is changing with respect to time and magnetic field is also changing with respect to time. So both are the sinusoidal functions of the time. The spectrum of electromagnetic wave covers the extremely broad range of frequencies and wavelengths. Dear students, to understand this situation, we are using Faraday law, which tells us that time varying magnetic field acts as a source of electric field, as shown by induced EMF in induces and inductances and transformers. In 1865, the Scottish mathematician and physician James C. Maxwell proposed that the time varying electric field could play the same role as a current as an additional source of magnetic field. Look at this diagram. In diagram A, you can see here blue lines or blue circles are representing here electric field, and here in diagram B you can see that green circles are showing the changing magnetic field. Actually, circle gives us continuously changing or continuously varying position. So blue circles are representing here electric field and green circles are representing here magnetic field. Now look at this diagram C, in which both electric and magnetic fields are present, and you can see that magnetic fields and electric field both are perpendicular to each other. Simultaneously, when the magnetic field changes, the electric field changes, and so when electric field changes, the magnetic field changes, and the process goes on and on. Now we are going to discuss how we could be able to generate electromagnetic wave. The fundamental requirement of the generation of electromagnetic wave is to accelerate a charge. Remember, when we gives acceleration to a charge, its velocity will change, and as the velocity of the charge changes, its electric field changes. So when electric field changes, so as the magnetic field changes. So the charge with changing velocity causes the electromagnetic wave. In an alternating current, an electron oscillates in the simple harmonic motion along the length of the wire, which means simple harmonic motion is back and forth motion about its mean position. So in alternating current, charge move forward and backward. So electron moves forward and backwards, which causes acceleration in the charge or electron, due to which electric field changes so as the magnetic field changes. This picture shows the wave of the radiation field far from antenna. Observe that electric field are and magnetic field both are perpendicular to each other, and also both are perpendicular to the direction of propagation. Now see, this red line shows the electric field and blue area shows the magnetic field. Initially, when electric field goes up, so as blue line, which representing magnetic field, goes perpendicular, moves perpendicular. So as the electric field changes in y direction, so as the magnetic field changes in z direction. And you can see that the electric field and magnetic field both are perpendicular to each other. Also, both fields are perpendicular to the direction of propagation. So if this is the direction of propagation, then you can see that electric field, which is represented by a red line, is perpendicular to the direction of propagation, and magnetic field, which is representing here by the blue lines, also perpendicular to the direction of propagation. Now dear students, we can understand this whole scenario by these examples. Electric and magnetic field generating electromagnetic wave. This plot shows a snapshot of electric and magnetic field at a particular moment in the time, and you can see that at this point electric field is it's on maximum point, and simultaneously the magnetic field also in the maximum position. So here electric field is reducing, you can see here, so as the magnetic field also reduced, and both are perpendicular to each other. And in this situation you can see electric field has changed its direction, so as the magnetic field also changes its direction. So as the electric field increases in this direction, you can see the magnetic field is also increasing in this direction, and both flows perpendicular to each other. Now dear students, in second example, the field electric and magnetic fields are perpendicular to each other, and the propagation direction v of the wave is along the direction defined by right hand rule number 2. This right hand rule number 2 can be explained. Stretch your right hand fingers in the direction of electric field. Stretch your right hand fingers in the direction of electric field, which is upward, and then bend your right hand fingers towards the magnetic field. You can see the orange line shows the magnetic field. So whenever you will stretch your right hand in the direction of electric field, and when you bend your right hand fingers towards the magnetic field, now this thumb is pointing in the direction of the propagation or direction of the velocity of electromagnetic wave. This is called second right hand rule, which is used to show the direction of electromagnetic waves. Dear students, now look at this picture in which from bottom to top, wavelength is increasing, and from top to bottom, the frequency is increasing. Here are the different radiation sources with the help of which we can generate different kind of electromagnetic waves. These are the different frequencies for different ranges, and these are the different wavelengths for different kind of electromagnetic radiations. Now here, these are the detectable objects which can show the size of the wave or wavelength of the wave, just like the particle accelerator or radioactive sources are used to generate gamma rays. The range of the gamma rays would be between 10 raised to the power 24 up to 10 raised to the power 20 hertz, and its wavelength would be 10 raised to the power minus 12 up to 10 raised to the power minus 15. And the size of different kind of gamma rays may be in the region of proton, size of proton, or size of nucleus, or maybe size of atom. Remember another thing, that whenever the frequency of the electromagnetic wave increases, its wavelength decreases, and when the frequency of the electromagnetic wave decreases, its wavelength increases. Now here is a chart from which we can understand different conditions and properties of different electromagnetic waves. So number one is radio wave. The range of the radio wave are from few kilometer up to 0.3 meter, and its range in frequency is from few hertz up to 10 raised to the power 9 hertz. The source which can generate electromagnetic wave, radio wave, is oscillating electronic circuits. This radio wave can be used for radio and TV broadcasting. Second is microwave. The wavelength of the microwave is from 0.3 meter up to 10 raised to the power minus 3 meter. Its range in frequency is 10 raised to the power 9 hertz up to 3 into 10 raised to the power 11 hertz. And we can produce microwaves with the help of oscillating electronic circuits. The microwave can be used for radar, analysis of fine details of atomic and molecular structure, and microwave oven. Number 3 is infrared wave. The range of wavelength of infrared wave is 10 raised to the power minus 3 meter up to 7.8 into 10 raised to the power minus 7 meter. Similarly, the frequency of infrared wave is 3 into 10 raised to the power 11 up to 4 into 10 raised to the power 14. The source which we use to generate infrared wave is molecules and hot bodies. Remember, hot bodies produces infrared radiations. Human bodies also maintain some temperature, which you know is about between 37 and 38 centigrade. So human bodies also generate infrared waves. The uses of infrared radiations are industry, medicine, astronomy, night vision device, greenhouse, revealing secret writing on ancient walls, etc. The visible light, or the part of the spectrum which is visible to human eyes, are its range of wavelength is 7.8 into 10 raised to the power minus 7 meter up to 3.8 into 10 raised to the power minus 7 meter. The frequency is in the range of 4 into 10 raised to the power 14 hertz up to 8 into 10 raised to the power 14 hertz. The source which generate this visible light is atoms and molecules when electrons are excited. We can use this visible light for seeing different atoms, optics, optical instruments, usual or normal visions, and photography. Number 5 is ultraviolet rays. The range of the wavelength for ultraviolet radiations are 3 into 10 to the power 8, 10 to the power minus 7 meter, up to 6 into 10 to the power minus 10 meter. Its range of frequency is 8 into 10 to the power 14 up to 3 into 10 to the power 17. The source which can generate ultraviolet rays are atoms and molecules in electrical discharge tubes. Also, sun produces ultraviolet radiations. The uses of ultraviolet radiations are medical application, sterilization, killing bacteria and germs, foodstuff, detection of invisible writing, forged document, fingerprints, etc. Number 6 is X-rays, which has wavelength about 10 to the power minus 9 up to 10 to the power minus 12. Its frequency may be up to 10 to the power 17 from up to 10 to the power 19. The source which is used to generate X-rays are inner or more tightly bound electrons in atoms. The uses of X-ray are X-ray photography, treatment of cancer, skin disease and tumor, locating cracks and flaws in the finished metallic objects like cars or aeroplanes, detection of smuggled goods in the bags of person in airports especially, study of crystal structure. And finally, number 7 is gamma rays. They overlap the upper limit of X-ray, which means 10 to the power minus 10 meter up to 10 to the power minus 14 meter of wavelength. The range of frequency of gamma rays are 3 into 10 to the power 18 up to 3 into 10 to the power 22 Hz. The source which can generate alpha rays are radioactive substances, and gamma rays are uses to show the information about structure of nuclei, astronomical research, etc. Dear students, your today's assignment is what is the function of electrocardiography and how we use electromagnetic waves to generate graph of ECG. Thank you very much. For any queries or questions, you can email us at the given address, or you can contact us on the number which is given below, or you can send us message in our box. Thank you.